Okay, so getting close to wrapping it up, guys. For this, we're going to talk about mass calculations for reactions. So here's a fun example for you. When you have a mixture of acetylene and oxygen, this undergoes combustion during the welding of metals. We can calculate the mass of acetylene used to weld a specific mass of the metal. So what is our learning goal for this is given the mass in grams of a substance in a reaction, we're going to be able to calculate the mass in grams of another substance in the reaction because, again, everything has to be equal. So when the mass of A is converted to the mass of B. So given a balanced chemical equation, we can convert the mass of one substance A to another substance B by first converting the mass of a substance A to moles using the molar mass of A. And then second, we're going to convert the moles of the substance A to the moles of the substance B using the mole ratio of B to A in that balanced equation. And then third, we can convert the moles of substance B into grams using the molecular mass of B. So here is a nice little setup. So for substance A, the grams of A, the molecular mass of factor A, the moles of A, and then the mole to mole factor of B to A. And then that would give you the moles of B, molecular mass factor B, and that would end up giving you the grams of B. So your handy dandy little guide is step 1, state the given and needed quantities in either moles or grams, and then write a plan to convert these to the needed quantities. Use the coefficient to write the mole to mole factors, and then write the molar mass factors if needed. And then step 4, use the problem to give the needed quantity in moles or grams. So suppose that we want to determine the mass in grams of NH3 that can be produced from 32 grams of N2 in the following equation. N2 in the gas state plus 3H2 in the gas state equals 2NH3 in the gas state. So how to do this? Step 1, state given and needed. We were given 32 grams of N2 and we need the mass in grams of NH3. Okay, and there's the formula. So step 2, let's write a plan to convert the given to the needed quantities. Okay, so we have the grams, and we're going to need the molar mass to convert it to moles, and we need the mole to mole factor to get the moles of NH3 from N2, and then we're going to get the molecular mass, and then we're going to be able to calculate the grams. So suppose we want to, again, determine this using the question. Okay, so step 3, using the coefficients to write mole to mole factors and write the molecular mass, the molar mass factors if needed. And so 1 mole of N2 is 28.02 grams of N2. And again, it can be written in 2 different ways. 1 mole of NH3 is going to be 17.04 grams. And 1 mole of N2 is going to be the equivalent of 2 moles of NH3. And that's how we can set that up. All right, so let's set up the problem to give the needed quantities and so that we can cancel things out. Okay, so we're going to carry this out 2 sig figs, 4 sig figs. This is an exact measurement, 4 sig figs, 2 sig figs. Okay, so I know your guys' favorite is significant figures, right? All right, so what did you guys figure it out? So how many grams of O2 are needed to produce 45.8 grams of Fe2O3 in the following reaction? Okay, so this is another problem, obviously. So pause me and come back. All right, so given and needed. We are given the grams of Fe2O3, and we need the mass in grams of oxygen. So what are we going to do? Well, let's write a plan to convert the given to the needed. Okay, so we're going to be going from grams of Fe2O3 to moles, to grams. Okay, so now let's use those coefficients to write the mole to mole factors and write the molar mass factors again if needed. So 1 mole of Fe2O3, right, is 159.70 grams. Okay, and then 1 mole of N2, and this is going to be the 2 moles of NH3. 1 mole O2 is 32 grams of oxygen. So let's set it up so that things cancel out. Okay, so we can see that the answer would be B. Okay. All right, last question. The reaction between H2 and O2 produces 13.1 grams of water. So how many grams of oxygen are reacted? So here's your setup. Pause me and work on the solution. So we're going to state the needed quantities, and then we're going to write the plan to convert the given to the needed. And then we're going to use coefficients to write the mole-to-mole factors. Okay, and then we're going to set it up so that those cancel out, and we end up getting 11.06 grams of oxygen. All right, great job today, you guys. Have a good one.